Hi guys, it's about 4:20 Eastern, 3:20 Central on this Friday, October 12th, 2012. I'm Stephen Boyle. This is my fifth of winter 2012-2013 winter outlook. Alright guys, so you all know that I put out a winter outlook last week, okay? And then I deleted it. And I know some of you have been asking me why. And I sort of want to answer that here, and I also did put a comment also on it. But so the reason why I deleted it is, well, I've been looking at a lot of videos on YouTube here, and also websites. And let me just tell you something. When it comes in terms of my winter outlook, I want to give you guys the best information possible. Also, I want to be able to support my claims with scientific data and information. And I want to be able to show you guys where I'm coming from. Okay? I don't want you to be I don't want you guys just to think, oh, this guy is just drawing colors on maps. Okay? No. And I've been looking at some of these forecasts, and I'm not gonna mention names. I'm not gonna mention anything because I just don't want people to get mad at me. But there are some videos out there where they are not supporting their claims with scientific information. Okay? It's just very, very off. Let's just say that. And you can't just have a forecast and just put it out, and it's a lot more intricate than what it seems. It's a lot more in depth, very in depth. Okay, you have to look at a lot of things before you can put out a winter forecast. All right, and so that's what I sort of wanted to tell you guys. And what I'm trying to say here is just be very careful when it comes in terms of believing accusations that you have on that you hear from other videos or websites or things like this, because you need that scientific data to support what your claims are. All right, and in this video I am going to get very intricate here. Some of you may at times be like, what is he saying? I don't understand what a word he is saying. It's so confusing. Well, if you have any questions at all, whether it's how much snow are we going to get in my area this year, or what the heck is a sea surface temperature anomaly, whatever you want to ask, okay, instead of asking below and commenting, what I suggest you do, because I want to be able to answer your questions thoroughly, okay, what I want to do is, if you ask me, whether it's through commenting or even through personal messaging here on YouTube, what I will do is I will send you links and directions to get to be able to chat with me and a NOAA meteorologist verbally. Okay, so if any of you have a microphone, this will be a very good opportunity for you to be able to ask your questions, and instead of me typing it out, all right, you will be able to hear me tell you your answers, or even a meteorologist. And the reason why I'm doing this is because I want you guys to be able to get the information that you need, okay? Because the winter forecast is a very big thing, okay? A lot of people have plans. A lot of people have plowing companies. A lot of people have skiing things, they have a lot of activities that they want to do, or they just want to know, hey, do I need that shovel or snowblower this year? There's a lot, okay? There's a lot riding on this. So if I encourage you all to just go ahead and ask me for those links and addresses here, and I promise I will give them to you, because it's very important that you get the best information. Now, again, I don't even, and against what some of these people are mentioning, you know, going back to that for just a second, I don't even consider myself a meteorologist, because anybody can call themselves a meteorologist, but I don't want to call myself a meteorologist because I don't have the education yet. I don't even consider myself a student meteorologist because I'm not even in college yet, although I'll be in it in a year, or actually less than a year, actually. But I don't even consider myself a student meteorologist yet. I would consider myself an amateur forecaster. All right, I'm on my way to. I'm very close to getting to that student meteorologist level, but I'm not quite there yet. Okay, but I do research meteorology a lot. Okay, so I do know a lot for my age, but you know, there's still a lot that I can learn, and I don't know everything yet. Okay, and when it comes in terms of forecasting the winter, it's very, 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 very intense. Okay, there's a lot of information that goes into it. A lot of information. So that is the situation. That is what I sort of wanted to tell you guys before I started my forecast. Also, one other thing. Someone mentioned a comment on one of my videos on whether I accept donations or not. Here's what I'm going to say about that. If you guys truly believe that I deserve a donation, if you truly believe it, then but I don't want you to think, oh, he's asking for a donation, so I have to donate. No, absolutely not. If you don't believe I deserve, if you know, I don't want you guys to think, oh, he needs a donation. No, I don't need a donation. But if you think I'm that good, and if you think, you know, if you really like my forecast that much, then yeah, but you have to truly believe it. I don't want you to just do it just because I'm mentioning it. All right, please don't do that. I'm not trying to pressure anybody into doing it at all. But I do know that someone commented. If you check out one of my videos, someone did comment, and I also commented back with those same words, but you know, I sort of wanted to mention it here so that you know, if that thought runs into anybody else's mind, you hear it. So just wanted to say that out, and you know, let that be known. So that is the situation. So let's get to the winter forecast. All right. But I just wanted to talk about those things first before I began, because those are sort of setting the stage for the winter forecast and or important questions that have came up. All right, so what you're looking at right now is the models and what they are predicting for when it comes in terms of the ENSO. Now, what the heck is an ENSO? Well, the ENSO is the waters in the equatorial Pacific. All right, they are the waters in the equatorial Pacific. Now, what this model is predicting is whether those waters are going to be above average or whether they're going to be below average. Okay, so are these waters going to be above average for temperature, or are they going to be below average? Now, when these waters in the equatorial Pacific are above average, so and these are the values on your left. Okay, these are the temperatures in degrees Celsius. Okay, if they are above 0.5 degrees Celsius, Okay, above average is what I'm trying to say here. So if they're 0.5 degrees above Celsius or higher, okay, degrees above average, 0.5 degrees Celsius above average or higher, then that is considered an El Nino. Alright, that is considered an El Nino if it's 0.5 degrees Celsius above average or higher. Okay, then you have negative 0.5 degrees Celsius below average or cooler. That is considered a La Nina. Alright, that is considered a La Nina. Now, what is weak? Weak is usually considered between 0.5 to 1. Alright, so from 0.5 degrees above average to 1 degree Celsius above average, that is usually considered weak. Moderate is usually considered between 1 to 2 degrees Celsius above average. Okay, within that general region. And then strong is 2 to 3. 2 to 3. All right. So that's usually how it runs. All right. Now, what about this area in here? This is neutral. Okay. This is if you're between 0.5 degrees above Celsius or degrees above average, degrees Celsius above average, or negative 0.5 degrees Celsius below average, or you have 0 degrees Celsius, neither above average or below average. Okay, that is neutral because you're generally at average. Okay, and if you notice what the models are doing, or if you notice where the models are, this from here to here is the winter. So this to this. Okay. If you notice, most of the models are within the neutral range. This is where they are centered at this point. Okay. But if you overall look at where neutral normally is, they are all within that neutral range. All right. They are all within there, within that range of coverage. All right. So that is the situation when it comes in terms of when it comes in terms of what's going to happen with the ENSO. Why is this so important? Well, there was a lot of meteorologists that were saying, we're going to get a weak to moderate El Nino. I was even saying it. Well, because the models were showing that it was going to go, above. Okay, but there are still some meteorologists right now that are coming out with forecasts that are saying, hey, there's going to be a weak to moderate El Nino, and that's just not true. They are showing that it's going to be generally neutral. Okay, now this is going to have a very minimal effect on what's going to happen here in the East Coast and actually across the country, but it will have a little bit of an effect on people in the South a little bit. Because, you'll see with my temperature outlook, it's going to affect the way that the temperatures are going to come into the country, and that will affect, and that has affected my forecast. But it's not a major change, but it may be a major change for people down in the South. Here is my forecast when it comes in terms, not my forecast. This is actually the CPC's, Climate Prediction Center's forecast when it comes in terms of the teleconnections. All right, this is a very important aspect, and really, this is probably one of the most important aspects when it comes in terms of what's going to be going on over the next few months. We have so right off the bat here, we have two very important teleconnections that we're looking at here. We have the AO and the NAO. There's also another one that's not on here. That's also called the PDO, okay? All three of those are very, very important when it comes in terms of also the AMO, which I'm going to show you just after I show you these. But the PDO isn't on here, but the NAO and the AO are the most crucial when it comes in terms of forecasting how intense the winter is going to be on the East Coast or even across the country. Now, when it comes in terms, so what the heck is this AO, NAO stuff? The AO, which is what you're seeing here, this is the Arctic Oscillation. The Arctic Oscillation is essentially the polar vortex, or the vortex of cold air that is up in the Arctic, and how far south that is coming down. When it's negative, it goes more, when the AO is negative, what that goes ahead and allows the cold air to do is come more south. All right. Now, if you have a lot of negative NAO during the summer, well, that Arctic air doesn't go as far north as what you would normally see, so therefore you have a little bit of a cooler summer. But notice how we did see quite a bit of positive AO during the summer, particularly through July up through the beginning part of September. After September, we saw a bit of a decrease, and then we saw that increase in the beginning of October, which is the reason why we saw very warm weather, and then now that's starting to go a little bit, that's going negative. But this is actually nothing compared to what we were seeing last year when it comes in terms of the AO. The AO was much, much more positive last year at this time than what it is now. Now, what's very important is when it comes in terms of October, it's very important to look at the AO and also the NAO in a minute. It's very important to look at this because out of all of the winters, okay, and what the AO and the NAO do, 3/4 of the time, all right, 3/4 of the time, what happens in October happens in the winter. And this goes not only for the AO, but for the NAO, okay? Now, notice how we are negative through, this is the 1st of October right here. I'll mark it up here. This is the 1st of October. Notice how, for pretty much since the 1st of October, okay, after this line, we have been negative. Overall, I mean, there's some models saying that this may go a little bit positive, but overall, if you look at the majority of the models, they're predicting negative conditions with the AO. That's very important because what happens in October generally shows you what's going to happen in the winter. Now, that's not even the most important part. The most important part is the NAO. And again, 3/4 of all of the winters, okay, what happens with the teleconnections in October will 3/4 of the time happen in the winter. Here is the 1st of October. Notice how we did briefly go positive, but that is nothing compared to what we were like last year. Last year we were like way up here with the NAO. Notice how generally we've been positive and we're really going negative, or excuse me, we're generally negative since October 1st, and we're really going negative now. So very good indicators of what's to come here. All right. Now, that's not even the beginning here. That's not even really looking at this isn't really even going to necessarily determine what's going to happen in the winter. What's the most important thing is this. This is what we call the AMO, or the Atlantic Multi-Decadal Oscillation. This is a very important tool when it comes in terms of figuring out, hey, is there going to be a negative NAO this year, or is there going to be a positive NAO? All right. Now, notice how you see, now this was back, I'm going to sort of mark something up here. This was back in 2010, okay? And notice how you have to look very closely, and I hope you guys can see this, but notice how there was a brief cooling period just after, this is 2010 right here, okay? This line right here. Just after 2010, there was a brief little cool down with the AMO. Very important, because when you see the AMO cooling, well, what happens is what that goes ahead and allows the NAO to do is go positive. Okay. Now, with that being said, the AMO is warming quite significantly. All right. So that is telling me that, hey, we're going to be talking about quite a negative NAO and quite a negative AO. And with that being said, and it's warm, the AMO is warming right now as we speak, and that is being shown here with the NAO. Look at that. It's negative. And overall, if you look since June, it's been negative. I mean, there's these, little peaks here and there, but it's nothing major. Then you look at the AO, and I mean, although that's that we've been seeing a little bit more in terms of positive here, or what we would call neutral, it's going quite negative now. Okay, so that's very important. So overall, this is the major part. This part that I was sort of talking about here with the oscillations are very important. Now we also have the PDO, which is the Pacific Decadal Oscillation. There is a area of warm waters just to the south of, in the central part of the Pacific, just, I would say, maybe a couple or a few hundred miles south of Alaska. And what happens here is you have cooler waters that go around that area of warm water. And what that goes ahead and allows it to do is you see this cool air stream up with the, and what happens is you get this cool air with the northern stream, and that just unleashes itself down into the eastern portions of the country. So there is a lot of information here that is pointing towards a very cold and snowy winter for the eastern portions of the country. Okay, now here is my temperature outlook. All right, now, and notice I want to sort, before I talk about this. Now, notice how I'm saying that this is not a final forecast, okay, because it's not, all right? This may change, all right? But overall, chances of this changing are very, very slim, but, we'll see what happens. But overall, at this particular time, what's going to happen here is we are going to have above average conditions here in the Northwest, okay? Now, you're looking at this and saying, Steven, there's snow happening right now in Wyoming and Colorado. So why the heck are they going to be above average? Well, above average doesn't necessarily mean no snow. No, that's not what it means. And again, we're talking about mountainous areas, and some of these mountains in here we're talking the Rockies, and the Rockies are, some of these mountains are like 10, 14,000 feet up. Obviously, it's going to be cold enough to snow in those areas, okay? It's pretty obvious, all right? So, no. I'm not saying that these areas are not going to get snows. They will get snows, but it's not going to be they aren't going to see as much as they would normally see in a normal year, or if we were to see cooler conditions, okay? And actually, sometimes cooler conditions doesn't even necessarily mean above average snow either, but in this case it is. But overall, all right, we are seeing warmer air setting out into these regions, okay? Now, in all these other areas, you're seeing all this white or closer to average, and it's because the way how the pattern is sort of setting out is we do have a ridge here, and then we have more of an angular trough setting out in the eastern portions of the country, okay? Angular trough. What the heck is an angular trough? Well, an angular trough is a trough that's coming in at an angle. Instead of a trough coming in like this, all right, you see a trough coming in more like at an angle, more like this, all right? And that's kind of an important key here when it comes in terms of what's going to be happening through the winter, because when you see an angular trough, the cold doesn't go as far south. You don't get the cold going down into the Gulf of Mexico states, all right? you get cold sort of spilling into the northeast, okay, and that's really where the majority of the cold is. But I do believe that portions of the southeast will be below average, like portions of Tennessee, portions of northern Alabama, northern Georgia, and portions of South Carolina. All right, these areas will see below average temperatures, but not as cold as I was originally thinking. But these areas up in here, I'm telling you, man, it's going to be really, really, really cold. All right. When you have an AO going that negative, okay, you can generally bet your money that it's going to be bitterly cold in the Northeast. Okay, we're talking areas of we're talking northern Pennsylvania, pretty much the majority of Pennsylvania, the majority of New Jersey through all of New England and New York. All right, this is important because it's going to be really cold. All right, and if we sort of go back to the present, more of the present, all right, we're actually almost going to be hitting records tonight in my area. We're going to be 1 degree shy of records here in my area, and in other areas as well. All right, 1 degree shy. Now, when was the last time this happened? Well, you'd be saying, probably back in 2006 or something, or 2004. No, the last time that this happened was 1943. This was quite a while ago that we were and I'm talking about presently. Okay, when it comes in terms of tonight, we're going to be seeing temperatures dropping back into the mid-20s in my area. There's widespread. Go on weather.gov and you'll see widespread freeze warnings are being posted here. It goes all the way down into northern portions of Virginia. At least when I last looked, there were still freeze watches, probably frost advisories or even freeze warnings into some areas. But no, this is very cold weather. All right. And we have almost record cold that will be occurring into portions of the Northeast tonight. We're going to be talking about teens. Yes, teens in northern New York, northern Vermont, and parts of northern New England. That is cold. We're talking anywhere between 15 to 18 degrees for lows tonight. Now, you're saying, well, Stephen, how does this relate to what's going to happen in the winter? Well, we have a negative AO right now, all right, and it's expected to stay negative, all right? If it's getting this cold now, which this is expected when you have a negative AO, then in the winter it's going to be very cold. We're talking very cold, all right? So I'm just sort of trying to give you an understanding of what's going on here, all right? People can say that it's going to be below average, but you need evidence to support that. All right, you need evidence to support it. Okay. Here's a precipitation outlook. All right. Now, so you're looking at this and you're saying, well, so overall there is a growing drought situation into the Northwest. All right. There is a growing drought situation up into those regions. It's going to continue. This is going to be a major problem for them up there. People weren't believing me back in June when I was saying, hey, there's going to be some pretty well below average conditions when it comes in terms of the Northwest. And people were saying, well, the winter is when you see the most above average precipitation in the Northwest. They were saying, that's a bunch of crud. Well, it's going on right now. All right, we're seeing a growing drought situation there. And the drought situation in the Ohio River Valley is starting to recede. Okay? So, a lot of people didn't believe this. But it's happening. Now, when it comes in terms of what's going to be happening with precipitation, overall, we're going to be seeing most storms. And this I'm going to go into very much in depth in a few minutes, but overall you can expect above average precipitation for the Gulf Coast region all the way up through the Northeast. These regions in here could even still see some pretty good intense storms. But overall, these areas are going to have more of what we would call a front-loaded winter. What does that mean? Well, front-loaded means that we're going to get more snow in the first half. Why? Because we are going to see more storms taking a more western track or coming down from Canada in the first half. All right. Once we get to the second half, we're going to really be ramping things up, and we're going to see storms coming up the East Coast, and there's not going to be as much back here. But there's going to be cold back here. But I'm still thinking that that these areas will still be in the action from time to time during the heart of the winter. But overall, the major action will be occurring right on the East Coast. So here's precipitation type. Now you're looking at this and you're saying, well, what about some people are saying, well, Stephen, weren't you talking about ice earlier? Weren't you talking about this? Weren't you talking about that? Can you and I know one of the things is can you explain why you don't have this snow as far south as you originally did? I would be more than happy to explain that. And again, this area in here is going to be on the dry side. Before we get into what's going on here and up in here, you see all these gray areas where I say equal chances rain and snow or average. I should say rain/snow or average, because overall these areas will see normal conditions, or they have an equal chance of seeing rain or snow. Overall, these areas are going to be sort of out of patterns, but they'll still see precipitation from time to time. But overall, the driest situation will be going on into the northwest. All right, so the rain will be generally staying pretty far south. Okay, now we are going to have mixed storms into these regions. Okay, for a lot of the southeast, we're talking the majority of the northern half of Georgia, the majority of South Carolina, the majority of North Carolina, all the way out into parts of New Mexico. Okay, now why is this happening? Well, we have what we call a boundary layer. Okay, and this is where we're gonna this is from here, and also the next the next graphic I have. This is where you're gonna start saying, Stephen, what the heck are you talking about? I'll explain. Don't worry. The boundary layer is essentially, to say it in normal terms, without getting, like I said, too scientific here, the boundary layer is the line that separates rain and snow. Alright? If you're north of that boundary layer, it's going to be snow. If you're south of that boundary layer, it's going to be rain. But what about right on that boundary layer? What's going to happen? Well, right on that boundary layer, which is generally going to set up somewhere in here, you're going to see mixed storms. Okay, you're going to see mixed storms. You're going to see rain and or snow. Rain change into snow, or snow change into rain. One of those sorts of situations, all right? Because this is where the boundary layer will be generally fluctuating in between, all right? And at times you can get, there could be some just plain old snowstorms, especially in the northern portions of this pink area. But I would expect generally, don't be surprised to see some rainfall. I don't expect too much ice this year. The conditions are just not favorable this year for major ice storms. The conditions are not there for a lot of sleet situations. It's going to be more of a rain-snow situation. It's either you're going to get the rain, or you're going to get the snow, or you're going to be in that area where it's going to switch. Okay? And sometimes you're going to look about, especially into these areas, okay, into these areas, you're going to look just 30 miles to your north, and you're going to be saying, oh, come on, I want that snow line to come down towards me. Or if you're a snow hater, you're going to be like, yes, that's just to my north. It just won't come down, all right, because that boundary layer is going to be setting out into these regions. Okay, so if you're into those regions, you can expect probably something more of along the lines of a rain-snow situation. Okay, now, once you start getting into these regions, it gets intense. Okay, and you will notice this with my next graphic. I go really in depth with the weather patterns that are going to be setting out across the country. Now, there are some, and like I said, I'm not going to mention names, but there are some forecasts out there where they actually say that this either above average precipitation or above average snow and or both stop right in southern New England. No, not going to happen like that. All right. First of all, there's a few things here. First of all, if that was going to happen, we would be seeing storms right now. All right, if there's a low pressure system down here and it goes up the coast, we would be seeing storms going out like this, like they're suggesting. Okay, like some of these people are suggesting. And we would be seeing the rain stopping in southern New England. Okay? It's not going to happen like that. We are seeing storms when they do come up the coast. They come up and curve around like this. Now, why do they curve around? Because we have a Greenland block in place. Okay, and areas of low pressure don't like to go and interact with areas of high pressure, so the low pressure has to go around that high pressure. Okay, so this is very important because most systems are not going to just do a track like this. Absolutely not. They are not going to be just going out and not affecting northern New England whatsoever. Okay? No. They are going to be impacted just as severely as southern New England, as New York City, as Washington, and as the mountains of Virginia and North Carolina. That is generally the situation. Okay? And these regions will get above average snow, but it will not be as above average as the Northeast. Okay, the Northeast will be quite above average. All right. Now we will also see above average conditions into the mountainous regions of California and southern portions of Utah and Colorado and New Mexico and Arizona. The reason why that's going to happen is we have a very active southern stream, which you'll see in just a minute, and that's going to go ahead and because these areas are in the mountains, that's going to go ahead and allow those guys to pick up some pretty good snows. All right. Now, here is the storm tracks, and this is a very intense, very, very in-depth graphic. Okay, and this is where I really want you guys to focus all of your attention on. All right. Now, as I was mentioning before, we have a split jet. We have a northern stream and a southern stream. The southern stream is supplying all of that moisture, all right? And if you go ahead to a water vapor imagery right now back out west, you will actually see this in action. You will notice how there is a massive storm system back out in California. This is actually going to eventually ride up into Michigan and cause some wicked intense weather up in here, all right? Now, and that's due in part because of the very active southern stream, and you will notice how there is cold air flooding down into the northeast ahead of this system. All right, it's all there. All right, it's just all there. Now, the southern stream will be supplying all of the moisture this year. The northern stream will be supplying all of the cold, and it's going to be a very dry stream as well. All right. So what's going to happen here is this northern stream is going to really look for precipitation and moisture. It wants that moisture. So what's going to happen here is right in Virginia, these two streams are going to phase. All right, they are going to phase, and what's going to happen here is we are going to see some very interesting storm systems. And what's going to happen here is there's a very intense, and this is also one of the things that is very important. There's a very intense sea surface anomaly right between the coast of North Carolina to the Delmarva Peninsula. Okay, right over to the Delmarva Peninsula. And what this is going to do to storms, and there will be storms that will go over this sea surface anomaly. And this has also been indicated on some of the models here. If you look at some models and you notice that they go over this area, you will notice that they intensify. Okay, why do the storms intensify as they go over the sea surface anomaly? The best way to describe it is, and as an analogy, it's like taking a match and throwing it into a can of gasoline. It's really intense, all right? What happens here is as the storm goes over this anomaly, it intensifies the low pressure, okay? And it's because this area in here is a little bit warmer than average, okay? And as it goes over that anomaly, it explodes, okay? These storms explode. And if you look at some of the models, and you notice that they go over this sea surface anomaly, you will notice that they get very intense. They just blow up, okay? Now, when these storms go over this sea surface, or as this is happening, these storms will actually continue to strengthen as they move northward. All right? What happens here is you can sort of think of an area of low pressure like a sandwich, and you have your upper level low pressure, you have your mid-level low pressure, and your bottom level low pressure. And essentially what you can sort of think about here is when it goes over this anomaly, it stacks. So you have the bread, you have your meat, and then you have the bottom piece of bread, and it stacks like that, and it gets the winds and the precipitation get more intense as that low pressure continues to stack. Now what happens is, as this storm continues to intensify and it gets bigger and bigger, first of all, it's going to move slower because it takes more of a force to push a very intense low pressure system, okay? It takes more of a force. It's like trying to push a car, all right? It takes a lot. It takes a lot of force to move that, all right? More than your average, normal, regular low pressure system, okay? Now, what's going to happen here is this storm is going to continue to intensify, all right? Because this is sucking up moisture from the Atlantic, all right? And what's going to happen here is you are going to see the low level pressure. It'll actually just drop. It'll just drop. It will essentially low level pressure will not be there anymore. And the reason why that is because it's just so strong. And when that happens, it will just be like going ahead and turning on a faucet, or actually a better example would be, you have a can of Coke. You go ahead and cut off the bottom of that can of Coke. The Coke that comes out of it is like the precipitation that would be falling when it comes in terms of these low pressure systems. And what happens with these very strong low pressure systems is, because that bottom has dropped, it will continue to try to bring in more moisture to get it to where it can move, and so that it can gain that additional so that it can regain that low level pressure that it lost. All right, so it's very intense. All right, and when you have a very intense storm like this, oftentimes it will become stationary, and what will happen here is you will have these 40-70 benchmark storms. All right, And it may not even be this massive, impressive storm system, but there will be a lot of 40-70 benchmark storms. But going back to that very strong storm, all right, that goes over this anomaly, it will still be riding in this 40-70 benchmark area. It'll unleash snow or precipitation, but most likely snow because of how cold the temperatures will be, not only for people in southern New England, but also northern New England, and also for the New York City area down through Virginia, northern and central Virginia. All right, it will allow snow for this whole corridor right in here. All right, and then as that happens, this low pressure system will continue to ride in this direction because there's a Greenland block up here, and the Greenland blocking happens because of the like I mentioned earlier, the warming of the AMO. All right, and although this H is a lot farther south than what I would like it to be, it would be normally way higher than that. I sort of wanted to show that there's a Greenland block, and what'll happen is these storms will go around that area of high pressure, and then curve back to they will curve back to the north. All right, so that's essentially what's going on. All right, it's very in depth. All right, it's very in depth. Notice how we have, and essentially these two storm tracks in here are the active southern stream storms that we're going to be seeing this year. We also will see some Clipper systems, but overall they will be dry until they hit into the northeast region or just off the coast, generally. All right, just off the coast is where they will start to strengthen and intensify. So that is the storm tracks and patterns that I'm expecting this upcoming year. It's going to be a very active year, folks. Finally, here are my total snowfall amounts for the winter of 2012-2013. Now, notice how it says this is not a forecast. This is a forecast, but I was supposed to put down this is not a final forecast. Sorry about that. All right, so overall, the highest amounts of precipitation will be, or of snowfall, will be in these regions, obviously. All right, obviously. But also these regions will still be into some of the good action as well. I do anticipate that. Now, you look at these areas and you're like, well, Steven, that's a lot of snow up into those regions. Well, some of these areas can pick up over 100 inches of snow a year on average. So, you know, and I'm not going to get so intricate that I get down to showing overall, the 60 inches plus that you're going to see in here, it could be below average for them. But this 60 inches plus over here is above average. Believe me, it's above. Also notice how it sort of comes down into some areas. You see how it sort of curves down. That is also above average snowfall down into these regions as well as into these regions. And there can also be localized areas that will pick up above 60 inches, especially into southern Utah and southern Colorado, northern New Mexico, and northern Arizona. The mountains of those regions could definitely pick up over 60 inches of snow into some locations. Notice how we do have 5 to 10 inches of snow coming down when it comes in terms of portions of the southeast. This is within a whole winter. This is, still quite a bit of snow for them, for you guys into these areas. Normally, you don't really get that much snow. You may only get an inch within a whole year. So 5 to 10 inches is a lot. Okay. Now, notice how you go just a little bit more to the north, and you're talking about 10 to 20 inches of snow for the whole winter. And now you're starting to talk about going into the mountains of North Carolina, going back into central Virginia, about anywhere between 20 to 40 inches of snow throughout the whole winter. All right, so that's through these areas. But overall, if you go through extreme southern Virginia and northern North Carolina, you're talking about 20 to 30 inches of snow for the whole winter. Now, once you start getting into the I-95 corridor, that's where things start really picking up. All right, you're going from generally Washington to about Philly, and you're getting about 40 to 50 inches of snow for the whole winter. All right, you go just to the north of that. We're talking generally from West Virginia through portions of the mountains of Maryland down into portions of New Jersey. We're talking 50 to 60 inches for the whole winter. Then you go between from, I would say, Buffalo, New York, back down into the into northern portions of New Jersey, all the way up into northern New England. We're talking 60 inches plus this year. So very, very intense. Okay. Very intense winter for these people in here. It's definitely going to be a massive winter. It's definitely going to be a massive winter into some areas. So overall, that is my forecast. Now, if you go back here, before we finish here, you notice how I have these few little dots here into portions of Washington State, and you're like, why do you have those little dots there? Well, those are really high mountain tops. Okay. We're talking about, I believe one of them is I forget the exact name, but it's a very high mountain in Washington. There's also, I believe it's Mount Olympus, which is right in here, and then you have another one in here. Very high mountains, and they can get over they will get over 60 inches of snow this winter. Because it's just their elevation. Their elevation will give them a lot of snow, but not as much as they would normally see. So overall, that's the general situation there. So, I mean, overall, that's my update here. It was a very long one, almost an hour. But I really needed to go in depth here and explain and sort of get you guys to know what's going on. So, sorry that it took so long, but I hope you all have a great rest of your Friday, and we'll be back in about a month, or in about a few weeks, with my final winter outlook. Take care, everyone.